For the better part of the last 30, 35 days, I've been spending most of my time in the morning learning Go. Primarily because I wanted to use a different language to do Advent of Code this year. The last 2 years I've done it in C Sharp. And in 2025, I wanted to do it in something else. And so somehow we landed on Go. I don't remember. Something chat recommended, and then the TypeScript compiler getting rewritten in Go. Something about all that culminated in I'm going to try to be a Go developer. However, I've really enjoyed it. I primarily write C Sharp and TypeScript, so Go is kind of a completely new thing to me, although it's been a very interesting experience because anytime you pick up a new language, typically you carry with it, you carry to it a lot of the learnings and philosophies and idiosyncrasies, idiosyncrasies, is that a word? That exist in the languages and the communities that you're coming from to the new thing. And then when you show up to learn the new thing, you learn about all their idiomatic approaches to writing code and solving problems and how what good code looks like and what's the proper way to build an API and what is a good design look like. It's interesting how much computer science is a science, but when you start talking about programming and coding, so much of it is a craft, and so much of it is a uh, thing that's built up on patterns and experiences and the learnings of others. And so it's been a really good experience. And so now that we're kind of actively in the in the advent of code journey, my time probably working a lot with Go is going to slow down. And so before I kind of make the transition back over to writing a lot of C Sharp and TypeScript, I just wanted to take a second and just kind of highlight some of the things that I really like about Go and really appreciate about Go. In particular, not so much the programming language, which I do appreciate, but I want to highlight some things that are more about the Go toolchain and why I think it's just so useful and so good for the overall developer experience. So the first thing I'm going to do is I've got a very simple kind of Go module set up here with just a couple files in it. So nothing fancy, nothing set up. I basically got a main.go file and a main underscore test.go. So that way I can put my tests in a separate file. Excuse me. And so the first thing I want to highlight right off the bat with Go is the fact that it has testing built in out of the box, no extra effort needed by you as the developer. It's just there, and it's really low effort to get started with. So the first thing I'm going to do here in my main.go file is I'm going to add a function called add. Now, we've probably all written this function several times before in our life. We've probably seen it in a half dozen different test-driven development tutorials that are out there. But all we're going to do is we're going to take two numbers, and then we're going to return a number that is those two numbers added together. So we'll just return A plus B. Now, the beauty here of Go is that in something like C Sharp or something like TypeScript, you would typically reach for some other piece of technology to help you facilitate the writing of the tests and the running of the tests. Yes, .NET has the .NET test command, and yes, Node has a built-in test explorer, but for the most part, the communities in .NET and the communities in the TypeScript and the JavaScript world have largely settled on using third-party tools and third-party packages to facilitate testing, right? Which is totally fine, it's totally okay. But it's really nice that those who developed the Go programming language and the Go toolchain thought, testing should be treated like a first-class citizen. It should just be there out of the box. So the way I can write test in Go is the first thing I'll do is I'll create a file called main underscore test, and that's how Go knows that in this file exists tests. And then in my main underscore test file, I'm going to add a function, and that function is going to start with the word test. That's important. And then I'm going to call it test add, right? Because why not? And then in this function, it's going to accept a parameter that is of type pointer testing t. And inside this function now, I can write my test. So what I'm going to do is I'm going to say, we expect a result of, let's say, 5. And so then we're going to say result equals the add function, and we'll add 2 and 3 in this case to get 5. And then we can just write a very simple assertion. Again, Go doesn't try to overcomplicate many things. A lot of the draw for people when it comes to Go is just the simplicity of the language. So instead of having some sort of assertion library, we can just use simple if statements and then that special T parameter to signal that our test should fail. So what we'll do is we'll say if the result does not equal what we expected, then we'll say T dot error F, and we'll say got %D, but wanted %D, and then we'll pass in those arguments to our formatted string. So we'll say we got the result, but wanted the expected, and then we'll write that out. That'll bring in the testing module, which has that special testing.t type that we're using in our function. And then we'll switch the other window that we have open in our terminal here. And again, it's just the test runner there is right there in Go. Just like with .NET Test, we can say Go test, and let's actually add a V flag for verbose just so that we see everything. And we'll go ahead and run that, and you can see we ran our one test, and it passed in barely any time. And boom, now we are ready to start doing the good test-driven development that we all should be practicing, right? Without any extra fuss. It's just testing's there. And so that's the first thing I wanted to kind of point out that I really appreciate. I know that's very biased of me as someone who works as a quality engineer, but the idea that testing isn't an afterthought is something I really appreciate. And the second thing kind of builds on this notion. So one of the common things we do a lot as somebody who primarily does web development is we write APIs, and we write a lot of web APIs, and we want to be able to test those web APIs. We want to be able to say, hey, if I give you this particular request of this particular shape, the logic inside my endpoint or my handler function should return the proper response with the proper shape. And that's something that's very common to do. But again, if you want to execute this in the .NET world or you want to execute this in the TypeScript world, you're right back to, well, I need to bring in some sort of third-party tool or third-party package to facilitate that. It's not just there. And in Go, it is just there. Again, they thought about this. This isn't some afterthought thing. They knew, well, there's going to be people who are going to want to build APIs and going to want to have to deal with requests and responses, and we need a way for them to be able to simulate that and test that without a lot of headache. And so let's add a very simpler handler function. So in Go, almost all your handlers that you write for basically route handlers are going to have a signature like this. So we'll define a hello handler, and the signature for it is going to be response writer, and we're going to have also a request, which is a pointer to the http.request type. And then inside here, all we're going to do is we're just going to write to the response the text hello world. We pass in the writer, and we pass in hello world, right? Which is great. But again, it's like, okay, so how do we go about actually testing this handler function? What's that going to look like? And Go makes it really simple. So let's go back over to our test function. And Go actually provides us with a particular package where all this functionality lives. So what we're going to do is we're going to come down here and we're going to add another test, and we'll call it test hello handler. It's going to have the same signature as our test above. And the first thing we're going to do is we're just going to create a request to actually test this. So let's do rec, and we'll just ignore the error for simplicity's sake here. That's not something that Go developers would be very happy about, but we'll just ignore it for now, and we'll just new up a new request to that get endpoint, and we'll do nil, and we'll bring in that HTTP module like so. And then the way we're going to get the simulated response from our request is we're going to create something called a recorder. And so we'll do HTTP test, which is the module that Go has out of the box to facilitate this type of testing. So we'll go ahead and bring that in, and we'll say .new recorder, like so. Then we'll create a new handler. So we'll say handler equals http.handler func, and we'll give it the hello handler function from our other file. And then what we can do is we can use that handler to actually serve a request. So we'll say handler.serve HTTP. We'll pass in our recorder. So our recorder basically acts as our response writer. It's actually going to be what get written back in response to the request, right? So you can kind of see where this is going. We can use that recorder now to get information about what response our handler generated based on the request that went in. And then we'll just pass in that request that we newed up earlier. And then once we have that, we can say, okay, well, what's the result? We can say, okay, well, the result is the recorder result. And now that we have the result, we'll check to see if that result actually gave us the status code that we wanted. So we'll say result.status code should equal, or if it does not equal, the expected status code, which in this case would be http.status OK, then we will basically print the same thing we did up here in our previous test, but we'll print it down here, and we'll say instead of that, we'll say the result is result.status code, and the expected is the http.status OK. That, and then again we can hop over to that other terminal, and we can do go test-v. And now we'll see we have a test for both our add method, which is a basic function, but we also have a test now for our hello handler function, which would actually be a function that would likely handle incoming HTTP requests if we were building something like a REST API or Web API using Go. But as far as testing it, it's really straightforward. We can basically just treat it almost like you would treat a normal function, with a little bit of ceremony to set up the request and set up the recorder, but that could all be abstracted away into some helper functions or some setup code to make your tests a little less verbose. But again, it's there out of the box. There's nothing extra you as the developer need to go and set up. Again, this is just, I think, like making the developer experience very simplistic, very straightforward, and treating testing as first class. I know it's biased, quality engineer, but I love this. So first class support for testing, and then second thing is first class support for doing HTTP testing, which I think is often kind of convoluted and overly complex in some other languages. All right, third thing we're going to look at. The third thing is, again, not necessary. None of these things are necessarily very specific to the Go programming language, but they are very specific to the Go toolchain. So the next thing we're going to look at is the fact that Go has the the next thing we're going to look at is Go has support for benchmarking out of the box, which I love benchmarking. There's a really great package in .NET called benchmark.net, I believe it's called, that you have to bring in as a third-party package to do a lot of benchmarking. This is built in to Go. It's very simple to do. So let's go back to my main.go file, and let's add another add method. But let's make an add method that, let's call it slow, right? So it does a lot of extra work for whatever reason. Who knows why? The developer thought it'd be a good idea to have a slow version and a fast version. And in our slow version, what we'll do is we'll just sum up this calculation a bunch of times. So we'll say range, let's say 1,000 or million, and let's do sum is going to be equal to a plus b. So we're not going to actually build up the sum. We're just going to run the calculation a bunch of times, and then we're going to return that sum. And actually, let's call sum total. That seems more apt. But we're going to needlessly run this calculation way too many times. But this is an example of where maybe you have two different implementations of a method, or you think you have another implementation of a method that might be faster than the one you already have, and you want to be able to essentially benchmark, well, is this one faster, or is this one slower, or does this one use more memory or less memory, right? These are things that you'd want to test and verify if you're doing some sort of optimization or experimentation with potential optimization. And the way you can actually benchmark this in Go is really straightforward. We can just use that same main.test file. And the only thing we're going to do different is instead of having it say test add, we're instead going to say we want to do a function that is a benchmark. So we just start with a benchmark function, and we can say benchmark add, and we'll pass in a b, which again comes from the testing package still. So instead of testing.t, we're going to do testing.b, which again is another type that comes off the testing module for us to facilitate these benchmarks. And then benchmarks can be as simple as this. All we have to do is we write a loop and we say b.loop, and then any of the code that we want to benchmark goes inside b.loop. So in this case, we'll just run add, and we'll do 2 and 3. And any setup or cleanup code that you would want to run for this benchmark setup code would go before the loop, and cleanup code would go after the loop. But any code that you actually want to measure as part of the benchmark goes inside b.loop. So let's also add a benchmark for the slow method. That way we can just have something to compare it to. So we'll do benchmark add slow, and then add slow here. And again, this is super easy to run. We just switch over to our other terminal and we do go test dash bench, and then we just tell go test that we want to benchmark all the benchmarks in this current directory or another directory, but in this case this current directory, and it will run our benchmarks. And it won't run all the tests, it'll just run the benchmarks. And it'll spit out some information about the CPU we're on, but then it'll tell you exactly what it did, how much time per operation it took. And then if you want to get memory allocations from your benchmarks, you can also do, what is it, go test dash bench, I think, and then the current directory in this case. And then I believe it's bench mem, like that. And so now it'll tell us not only the operations, but it'll also tell us what, if anything, was allocated per operation, which is pretty nice. And again, it's all there, just out of the box. I know it's really silly. I'm sure maybe you clicked into this video thinking, oh, Steven's going to put me on to some really cool stuff in the Go programming language. But really, I thought the Go programming language kind of was what I would expect out of a programming language that's aiming for simplicity. It's an interesting place between something like C# and TypeScript where I live, where you can sort of do, it's kind of a procedural language where you can do some functional style programming. It has some ability to do object-oriented style code, probably not completely like what you would expect coming from a .NET space, but you know, you can do it. You can kind of simulate it. But really, the stuff to me that really blew me away was just the tool chain. This ability to have testing out of the box, have the ability to test HTTP handlers out of the box, the ability to benchmark your code out of the box is just wonderful DevX, and I think helps build what Scott Hanselman talks about is this pit of success, right? As a developer, it helps you just lean into doing the right things, and instead of putting friction between you and doing the things you know you should do. So I hope this was helpful. I hope it gave you kind of a little bit of a taste of Go and maybe encourages you to maybe go and tinker with it for yourself. Again, it still didn't supplant TypeScript and C# as some of my favorite languages. It definitely put itself above Python, but it's another language that I'm really glad I know something about. I have some level of capability with it, and maybe when the right project or the right need presents itself, it's a language I'll be able to reach for and use relatively effectively. So if you enjoyed this video and found it helpful, I'd love to hear from you in the comments. Obviously, if anything I said about Go or any of this information is wrong, please feel free to correct me. I'm learning just like you guys, and I'm just excited to share what it is I'm currently learning and what I have learned with you. But obviously, I get things wrong, so it's not going to hurt my ego if you leave a comment and say, well, actually, Steven. In fact, I would actually appreciate that because I would love to be enlightened and make sure that I'm speaking correctly on these things. And with that, I'll leave you guys. Hope you guys are having a wonderful day, and I'll talk to you in the next one. Bye.